Okay. Maria, turn around. Okay. Here we go. Listen, some of us after the last test, some of us really need a good one this time. So let's make this one good.
We got like a C.
All right. So I've got 4 juniors and 5 seniors. Okay, I'm going to ask you some questions now.
Did you get to go to his house?
No, I was like, you do that.
Have you seen his bike?
Seated in a row.
I saw his bike out when I.
Seated in a circle.
He was real hot.
Each class together.
He wasn't. I just saw him.
And only juniors
You lucked
together.
out, man. I swear you fell. Never would have came back.
Okay. So on the test, we maybe ask one of these 4 questions. Let's see if we can answer them. All right, here we go. How many ways can I seat these people in a row? 9 factorial. We don't care that they are juniors and seniors. It's irrelevant. We just want to seat them in a row. How about if we seat them in a circle?
8
factorial. Remember on your test, you will be writing down numbers for this. So do make sure that tonight when you're practicing your review problems, that you are typing at least some of them in. I'm not saying you have to type them all in, but type enough in so that you get comfortable knowing what buttons to press. Okay, how many ways can I seat them in a row if each class has to be kept together?
2 factorial.
2 factorial. And why do we start with 2 factorial?
Because if you group them into classes,
2
there's
groups,
2.
right? But if you stop there, you're not going to get full credit because
4 factorial.
4 factorial, 5 factorial, because those 4 can be tied together 4 factorial ways, and those 5 can be tied together 5 factorial ways. Right? Only the juniors have to be kept together. So these guys can sit anywhere they want, but the juniors have to be kept together. 6 factorial, 4 factorial. Why 6? Because there's 5 and 1 more. And then that bundle is the 4 factorial. Okay, everybody good with that? All right, next. I got 21 students. How many ways can I award 5 identical prizes? How many ways can I award 5 different prizes?
21C5.
Identical prizes is 21C5. Exactly. Because there are 21 kids, I'm going to choose 5 of them. And the order I choose them doesn't matter because all the prizes are the same. But if I'm giving away pens, pencils, erasers, markers, and calculators, then 21P5. This is the fundamental difference between combinations and permutations. In permutations, order matters. Everybody okay with that? Okay, now we have 5 card hands, standard deck. 5 card hands, standard deck. How many hands? Contain 4 hearts? Exactly 4 hearts. How many hands contain at least 4 hearts? What's the probability of getting 2 diamonds, 2 clubs? So exactly 2 diamonds and 2 clubs. All right. On the test, these questions are all typed out nicely. I just don't want to take the time to write them all out. So you get the gist here. We have 5 card hands. Question 1. How many hands contain exactly 4 hearts? Ideas?
There's 52 cards. 13 cards. There's 13. Is there
There's 13 hearts.
So 13.
I couldn't hear you. What? 13.
That was a not confident
Not
answer.
confident answer.
13C.
13C4. I'm going to start that way. That is not the end of it.
Oh, and then 4.
39C.
Oh, no.
52.
39C1.
39C1.
Alright, now I get it.
That's it. Remember, it's a 5-card hand. If 4 of them are hearts, what's the other one?
Not a heart.
Not a heart. And how many not a heart cards are there? 39. 13 clubs, diamonds, and spades, right? So even though this is a mistake, I'm just warning you and warning you. The problem talks about 4 hearts, but it's a 5-card hand. So don't forget the other one. You got to have 5. All right. What about at least 4 hearts?
So that.
Now, would at least 4 hearts include this?
Yes.
Yes, because this is the 4 heart. Or what else could it include?
13C5.
13C5, and if you want, you can say 39C0, but you don't need to add that in there. Because what does 4 heart, at least 4 hearts mean? You get 4 of them, or you get 5 of them. Probability of getting exactly 2 diamonds and 2 clubs.
13C2.
13C2, there's your diamonds.
13C2.
13C2, there's your clubs.
Then 26C1.
26C1, where'd that come from? That's the
rest.
5th card. And it can't be a diamond and it can't be a club, so therefore it must be a heart or a spade. And there are 26 of those? Over. Why is this one over? Because it's probability. And what's it going to be over? 52C5. Perfect. Why are these multiplied?
Because they're ors.
2 diamonds
No, ors are
and
the plus.
2 clubs and 1 other card. Right? When it's this and this and this, we multiply. If it's this or this, we add. Okay.
I'm sorry. I'll place the other way.
Okay, so bowl A contains 4 blue M&Ms and 6 green M&Ms. Bowl B contains 5 blues
Just chilling.
and 2 greens.
Curious.
Pick one. What's the probability it will be blue?
I can see how they responded. They tricked me. Very safe drop and stack.
Bowler.
Did you see like a
Okay, so I want you to actually think about doing this. Pretend that on the table here there are 2 bowls of M&Ms. All right? You walk in the room, you're going to take an M&M. What is the first thing you have to figure out when you walk in the room and see these 2 bowls of M&Ms? What's the first thing you have to think about? Which bowl? So the first thing you're going to do is pick bowl A or bowl B. What is your probability of picking bowl A? 1/2, and B is 1/2. All right, so now you have picked a bowl. You have said, okay, this is my bowl. Now you're going to pick an M&M, right? And what's going to happen? You could get a blue one or a green one. out of either mold. We could get blue or green. Now, what's the probability that if you're in bowl A, what's the probability you're gonna get a blue marble, or a blue M&M?
2/5.
4/10. 2/5, 0.4, however you want to do it. Then the probability you're gonna get green one's 6/10, correct? Yes. All right, now what's the probability out of bowl B?
5/7.
5/7, sand, 2/7. Now the question said, what is your total probability of getting a blue? So you could get a blue this way, and that probability, if I don't reduce anything, that's 4/20. And I could get a blue one here, and that's 5/14. Right? So what's my total probability of getting a blue marble? Well, I don't know, I gotta add these, right? I gotta add those. And when I add those, I'll have to get a common denominator. And you're gonna have a calculator, so it's not gonna be an issue for you. But you're gonna add those together, okay? Remember, if you may answer the questions in fractions or decimals or percents, but if I were doing this, I can put in my calculator 4 divided by 20 plus 5 divided by 14. And it comes up with a decimal, but if I hit math frac, it puts it in a nice little fraction for me, 39/70th, if that's how I want to answer. You are perfectly okay answering as a decimal, if that's what you want to do.
Okay. She just kind
Right.
of
Is she really good?
Okay.
decimal, will you have us for?
Yeah, there's directions about rounding.
No, you're allowed to.
Okay, now we've got Harry is tardy, 1 out of 3 days.
She always says the same.
Isn't that good? I'm not gonna complain about that.
She's going right.
What's the probability? He'll be tardy exactly 8 of the next 10. Strategy.
Write this down. Exactly.
The probability.
Make a big old little tree thing.
You absolutely could make a tree diagram. It would be huge because there's 10 days here. So I will not choose that strategy, but it would work. It would work. What are you gonna do with Pascal's triangle? I mean, that just gives you some numbers. What do we do with those numbers? Aha, Maggie's on to something. Maggie says, instead of using Pascal's triangle, because this would be the 10th row, which would be a long way down. Maggie says, I need to pick 8 days that he's going to be tardy. Do I care which 8 days? No. So that would be 10C8. Just choose 8 of the next 10 days. This would be a number in the 10th row of Pascal's triangle if you wanted to do it that way. So 10C8. Now I have picked 8 days for him to be tardy. Every single day, he's either going to be tardy or he's not going to be tardy, right? Every day. I want 8 tardies and 2 not tardies. What's the probability he'll be tardy? And the probability he won't be tardy? There we go. Whatever that is, all times together. Again, decimal or fraction or percent, doesn't matter to me how you answer it. But you're going to put all that into your calculator and get a number.
Big things.
Let's do another one of those.
Hey Nice one.
We'll do another one of those. I have to yell at Ben 9 out of 10 days.
Precal.
What's the probability? I'll yell at him exactly 4 of the next 7 days. You see how these problems are exactly the same? Okay. Kind of look at them, kind of get a feeling for them, because one of your issues is we have so many strategies to do these probability problems, Venn diagrams, tree diagrams, combinations, we have all these strategies. Get a feeling. This is, as Maggie called it, a Pascal's triangle type problem. It's binomial probability. So what's the first thing we have to do? There's 3 pieces to it. What's the first piece? 7C4. There are 7 days in the problem, and we are going to pick 4 of them. We don't care which 4. Every single one of the days, I am either going to yell or not yell. I want to yell 4 times and not yell 3 times. Right? What's the probability of yelling and then not yelling would be 1/10? That will be the answer to the question. Okay, I have 10 shirts, 8 jumpers, 2 sweaters, 2 pair of shoes. How many outfits do I have? How many outfits do I have if I have all of this? Just multiply them all together. That's right, Mr. Preston. The answer would be 10 times 8 times 2 times 2, whatever that is. Notice there are no factorials. Yang, we're not arranging anything. Now, if I said how many ways can I arrange all this stuff in a row in the hallway or something, that would be different. But I'm just pairing all these things up with each other. Okay? All right, we have 5 mathletes and 6 football players. Okay, I'm going to pick a team of 3. I'm going to pick a team of 3. Okay, so these are the kids in the room. I'm going to pick a team of 3. Here we go.
Okay.
How many teams have at least 2 mathletes? What is the probability of a team having exactly 1 mathlete? No, that's it. That's it.
It's very easy.
All right, so what's your thought on A?
6 mathletes, 6.
Since it's at least, you have to find 2 or 3 or 4 or 5 or 6.
Well, I'm only picking a team of 3.
Team of 3. Oh, so it's just 2 or 3.
So 2 or 3, so I can do 2 or 3, okay, so what would 2 look like? You must do this as 2 separate problems. You can't do it in one step. It's going to be 2 separate problems. So 2 mathletes would look like what? You're picking out of this pile. 5C2 times 6C1. These are like the card problems. You're picking a team of 3. If 2 of them are mathletes, then what's the other one? Football player. Now, what about 3 mathletes? What does that look like? 5C3, 6C0. Again, you don't have to include, anytime it's a C0, you don't need to include it. But this does kind of remind you that you're picking from both groups. And then what are you gonna do with these two numbers? Add them. I'm gonna pick my team of 3. What's the probability of exactly one mathlete? 5C1 times 6C2.
Over.
Remember, it's a team of 3. No football players are mentioned here. But if there's only one mathlete, there's got to be 2 football players. And then divided by 11C3. Why 11C3? Denominator is always the total. How many total kids are there? 11. How many total am I picking? 3. All right, I've got 200 students. 70 love Mountain Dew. 60 love Pepsi. 12 love both. I'm going to pick one student. What's the probability of not liking either? Alright, so there's the deal. I got 200 kids in the room, 70 like Mountain Dew, 60 like Pepsi, 12 like both. I'm going to just randomly grab a student. What's the probability that he won't like either one? Alright, what's your thought on this? Venn diagram. Doesn't it feel like a Venn diagram problem?
Right.
So we draw our Venn diagram. We'll have a Mountain Dew ball and a Pepsi ball. And what are you going to fill in first? The part in the middle. Because that 70 is the entire circle, right? Do not put 70 here. What are you going to put here?
82.
What?
58.
Good work, Ben.
And then what are we going to put here? 48. Because the whole Pepsi ball is 60.
I don't feel you.
But 12 are already in the middle.
I'm already in the middle, so.
Now, how many people are represented inside the circles? 118. There's 118 people here, right? Well, what does that mean? If there's 200 kids in the room, but only 118 of them have raised their hands, that means there are 82 out here that didn't like either one. So if I randomly just reach in and grab a kid, what's the probability he won't like anything? 82 over 200. Which you're going to want to reduce. If your answer is a fraction, you're going to want to reduce it. Of course, if the answer is a decimal, it doesn't matter. Okay?
Didn't like it one day.
Going to town. Taking her to Pound Town.
Expand. How do we start this? What do we use the triangle for? Pascal's triangle. What do we use it for? To get the coefficients, right? So we can either write out, this is only the fourth row. This will be the fourth row, so that's easy to write out. So we're either going to write it out, or we're going to remember that the first number would be 4C4, 4C3, 4C2, and so on, whatever's easiest for you. Now, I am old. I have done a zillion of these, so I have memorized the fourth row of the triangle. You do not need to memorize it. Do not waste time doing that. I have it memorized just because I use it all the time. So there it is. Now what? Next step. I'm going to go through, and next to each one of these numbers, I'm going to have 2 parentheses. And in those 2 parentheses are going to be a 2x and a y. because those are the two pieces of the problem, right? Now what? Next step.
Put a 4 on.
We're going to put the exponents on. So I remember that if I were to multiply all this out, the exponent on the first variable, 2x, the exponent on that would start out as 4 and then go down. And the second variable, the y, goes the other way. Now, I like to separate these with plus signs so that I keep them separate, because now I have to look at each term, right, and simplify it. So anything that is 0 powers 1, so I don't need to worry about that. So what's my first term? 16x to the 4th. What's my next term? 32x cubed y. Next, 24x squared y squared. Next, and last, y to the 4th. Everybody okay with that? Along those same lines, find the 4th term. So this is basically the same problem, except instead of finding all the terms, you're only finding the 4th one. So this term, like all the terms, will have a coefficient and then the 2 parts of the problem. So what will be the coefficient here? If we were going to expand the whole thing, the first term would be 10C10, right? 10C9, 10C8, 10C7. The coefficient is 10C7. I just counted. The first term would be 10C10, 10C9, 10C8, 10C7. The 4th term is 10C7. You could also build your triangle out to the 10th row. Wouldn't recommend it, but you could do it and then find the 4th number in that row. What is 10C7?
120.
120. So your coefficient's 120. Now what's going to be next to that 120?
2.
A power of x and a power of negative 3y. Right, you guys? Now what will be the power on the x?
6.
Well, in the first term, the power on the x would be 10. And then it would go to 9 and 8 and 7. So the power on the x is 7. Making the power on y 3. Because when we expand to the 10th power, our exponents add up to 10. Logan!
Yeah, what's up?
Did you say what's up? I'd like it to be your grade.
Oh!
Now, here we go.
It's fun.
Now we simplify. So we're going to take 120
You just cranked out.
x to the 7
I should have, I just walked in.
and negative 27y cubed. This is a multiplication. So what's 120 times negative 27? Negative 2,
32.
3240. X to the 7 is y cubed. Everybody understand where the negative 27 and the cube y cube negative 27 and the negative came from? The negative and the 27. Everybody get it? All right, one more. By hand. By hand. I would like for you to calculate this and this. By hand.
I don't know.
Who remembers the formula for 15, well, for either one? Who
So, 15 factorial
They both start with 15 factorial over something. They both start with that, this number factorial on the top, always, always. This one is gonna have a 2 factorial, 13 factorial. Where did the 2 come from?
15.
Subtract, and then 13. So the combinations has 2 things in the denominator. You remember the permutations only has 1 thing? What is it? It's the difference, exactly, it's the difference. Now, if this is a by hand problem, you're gonna be asked to show that and then show your work to simplify it. So what have we got here? We've got 15 times 14 times 13, 12, and so on, over 13, 12, and so on, and then a 2 times 1. This is gonna happen every time. A bunch of stuff's gonna cancel out every single time. Everything from the 13 on is gone, right? So what do we really have? 2 goes into this 7 times, 15 times 7, which is 105. That's it. What about this one? What's gonna happen? You got 15 times 14 times 13. Isn't everything else gone? So your answer is just gonna be whatever 15 times 14 times 13 is.
Could I just enter 15 factorial into the calculator and
Except I'm asking you to do this by hand,
okay.
so I want to make sure you understand what factorial means, which I know you do. All right, those are the review problems I jotted down yesterday. Tell me what you have in terms of what kind of problem would you like to practice another example of? Is there any problem that you feel like we need or you need extra practice on? Okay, in your packet then, let's make sure you're clear on what your homework is.
Bro, Ben, I heard you were a narc.
Because I started how much yesterday. Oh, it's
Hey, narc. On Luke. Disrespecting us like, hey, the people on Saturday. It's like, nah, disrespecting us Ben. And Ben was like, oh yeah, it's that party.
No, listen. Wait, so did
All right, in your packet, you have a sheet. You have a sheet called 9.1 to 9.3 review. It says Precal A period 5 is the best class in the world.
I think they could have done the last season.
It's a single page.
I like how we all.
I do not have answers to these, so here's, in the packet, there are no answers to it. So here's what I'm gonna do, I'm gonna work them out, hang them outside the room. If you're interested, you can come by, take a picture of them, so you have the answers if you want. Now, you might say to yourself, well, Mrs. Ford, why don't you just put them on your website? I don't know how to do that. So I'm gonna just hang it out there, and you take a picture of it if you want the answers, okay? Ignore all those directions. This was an in-class exercise we did at some point. So you're just gonna do these 10 problems for homework. If nobody has any other question, you don't need to review any other, you've got everything we've talked about, so you're comfortable, then you've got 9 minutes to go ahead and get started on these problems, and I'll get started on them too. Thank you, John.